Hi everyone, Cody here. So I'm currently aggressively dismantling this fridge so I can get at the compressor and everything. So we got the compressor here, you can see. Camera can adjust. And so the high pressure side, so the direction the gas is being pumped is this way. So it goes up through this tube here, coils around a little bit apparently. It goes up, and it goes all around the outside of the box, as you can see here. This is because it gets hot when you compress the gas. So this goes around the outside of the box, radiating off its heat to the outer metal shell. Comes around here as well. Then it comes back through. You got a little thing here, which is just a little reservoir. Then it goes into a capillary tube, so the tube gets much smaller. Comes up through here, the capillary tube then goes up into this return line. So this is where the gas is coming back into the compressor. This return line is coming through, the capillary tube's going up through it, basically making a heat exchanger so it can expel even more of its heat into the gas which is going into the compressor. Then we come around here, the gas, which should be liquefied by now, is coming up through this tube here in the capillary. The capillary goes through here and then into this larger chamber here. See all these coils? This is where the gas, which was liquefied, then boils away and evaporates again, taking heat out of this box with it. Then it goes back through this thing, which we mentioned earlier, and then back into the compressor. It's actually pretty cool how these things work. I'm going to try to use a similar process to achieve much colder temperatures. You can see here my CO2 collection apparatus. I got some honey, about 10 pounds worth in about 5 gallons of water here, with some yeast that has been fermenting. I think it's still fermenting along, but as you can see, I've filled this here inflatable mattress with the CO2 produced by the fermentation. And this thing is just about full. So I got the compressor set up here. I'm going to hook this in line to this, and then hopefully be able to compress all of this gas down into a small space, release it suddenly, and make dry ice. Dryer here, with the calcium chloride having absorbed quite a bit of water, hopefully making the gas that went into this thing completely water-free. I'll go ahead and add a ice bath to that copper vessel there, just to make sure I can get as much water out as possible. I got the cylinder hooked up to this. Here's my ice. Here's the ice bath that'll be going for that. This one I'm going to be adding some calcium chloride to it, which I have right here. That should lower the temperature down to well below 0 Fahrenheit, and hopefully cold enough that I'm able to liquefy the CO2. Add a bunch of that in there. Excellent. Give it a stir. Hopefully there's enough salt in there. There's that. So the gas is theoretically going in, and hopefully I'll be able to suck down most of this and compress it in there. If not, then I'll know that it's not liquefying. Judging by the frost on that bucket, I can tell that it's very cold. Okay, it's looking like I'm gonna have to call it quits. This second motor here was beginning to overheat, and really there's nothing I can do about it. There's still a lot of gas left here, so I'll save this for the next time, I suppose. Although, you know, it does feel like a lot of gas has been taken out. Let's go ahead and try this and see if we can get any dry ice out of it. So I got that unhooked. This valve is closed, so hopefully I've contained all the CO2. Let's go ahead and open the valve into a rag and see if we can collect any CO2. Alright. Turn it upside down. Here it goes. I'm going to crack it loose. Okay, I'm going to go ahead and try this once again. This time I've added another refrigerator compressor. So that should add another 200 psi or so, and hopefully the gas is actually flowing into there and getting liquefied. This has been running for a few minutes now, and I can still hear gas flowing in. This is definitely decreasing volume, so we're definitely getting somewhere. And by the way, I know this is rather dangerous because I got a lot of pressure going here, but I have set this up so that the place that it's going to burst is right here in this copper pipe. The bottom edge of this is be the first place that'll burst. There won't be any shrapnel in or anything. It'll just make a mess, but you know, nothing I can't deal with. Anyway, I think I'm gonna call this quits because this thing is just getting way too hot, and I don't think it's even running. I think just the windings are just shorting out, like the compressor's not actually running. So let's go ahead and shut this off. However much gas we got in there is how much we're gonna get. Let's see how much CO2 we can make this time. Okay, here it is. Time for round 2, I suppose. Let's go ahead and let this gas out. See if we can get anything that resembles dry ice. You know what? That looks like dry ice to me. Look at that. I must have had some liquid there. It's sublimating away. Very nice. I think I've actually done it. I think it actually worked. A couple of minutes later, and this thing is evaporated completely dry. How about that? I think I finally managed to make dry ice using compressed CO2. Refrigerator compressors probably wasn't the best choice because they seem to overheat really quickly. I'll think of something better for making large quantities, but this was a good little proof of concept, proof that I could actually do it. Hope you guys enjoyed. I'll see you next time.